Good morning, everyone. I'm Brian Cantrill. I'm the co-founder and CTO of Oxide. It's great to have you here in our office, our playpen here. As you can see, we've had a lot of fun building the Oxide cloud computer. I want to talk a little bit about Oxide value, because this is something you're going to hear us talk about quite a bit, about delivering Oxide value, our capability to deliver Oxide value. But I want to be a little more specific about what that is. It's of course, it is the value that we deliver to our customers, but it's actually much deeper than that. It's how we approach the problem. It's our own rubric that guides us about the kinds of problems we pick up and how we pick it up, and how we actually deliver that. And for the origin of that, it's actually helpful to go a little bit back in time, because in many ways you can view the way we think of Oxide value as delivering for the market what no one has really been able to deliver. So for that, let's go back and kind of in the beginning. In the beginning, of course, it was all on-prem, right? And actually, in the very, very early days, computers were so expensive that folks realized that they had to economically share them. And it's funny if you haven't done it, going back and reading some of the writings on utility computing in the 60s, you're like, wow, this is very eerie. This is actually very much predicted cloud computing some 40 years later, but there was this big gap in the middle, right? This big gap in the middle where compute became on-prem in a way that the pioneers of compute couldn't even imagine. We had the personal computer market, right? The personal computers, we all had computers. That was a wild idea in the 60s. And when we kind of go into the 1990s, all of compute is on-prem. And if you want to actually, if you've got a service and you want to expand that service in the years 1999, you are getting servers, you are racking and stacking and cabling. And there's some crazy stories in the dot-com boom about folks that are frantically racking and stacking and cabling so they can get ahead of their demand. So this was the 1990s, and this infrastructure can't just be spun up, right? You've got to actually go like, computers in the 1990s arrive in boxes. They have to be deboxed. This is actually a lot of effort. If you've ever deboxed, it's one thing like, okay, yeah, how hard is it to debox a computer? It's like, well, when there are 40 of them, you really appreciate how difficult all that is. And all of this stuff has got to get racked, stacked, cabled. You've got proprietary hardware and software throughout. And this was painful. This was not, if you read these stories of the kind of the late 90s, early 2000s, this was a real drag on innovation. And one kind of concrete, there was a website called hotornot.com, terrible website, but they got a great story where they need to grow hotornot.com. I'm not sure, it's probably a terrible example because I'm not sure what value hotornot.com added to humanity, but they couldn't grow the service because they couldn't actually add enough physical servers fast enough. Fortunately, there were a confluence of trends that gave rise to an alternative. So we had a bunch of things that happened in the early 2000s. We had internet ubiquity, right? We needed internet ubiquity. That did not exist in the late 90s. But by the mid 2000s, getting into the late 2000s, we had internet everywhere. We had protocol maturity. So we could begin to really rely on the internet. We had the rise of open source. Open source was kind of a hobbyist idea. It's kind of amazing to think that the term open source is actually only coined in the 90s, the mid to late 90s. Before that, it was called free software, kind of other names for it, but it becomes ubiquitous in the early 2000s. We've got the dominance of x86 and quote unquote commodity hardware, where it kind of extinguishes everything else, and all the proprietary minis and so on have all died at the hands of x86 and its performance. And then honestly, I think that a big part of the rise of cloud computing is a total startup ice age that occurred in the post-dot-com bust. So, for those of you who lived through the bust, you know what that's like. I think that when kind of people complain about our current economic conditions, I'm like, the bust is much, much deeper. The bust was really deep because people in many ways just gave up on tech in many ways. And when you started a company in 2006, 2007, 2008, you had to be capital light, very, very, very lean. And all of these added up for both the demand and supply for true cloud computing. Cloud computing starts with Amazon S3 in 2006, but expands to EC2. We start having real services, shared, elastic, API-driven. So really API first infrastructure. So the infrastructure where you're thinking about the API and then building what's underneath it. The API is not actually an afterthought. So all of this gives rise to this terrific thing that we now use pretty ubiquitously, public cloud computing. That's great. But it also gave rise to a divide. And in the hyperscalers, who were the cloud computing operators, they were able to invest relentlessly in actually innovating. And they started out with those kind of commodity gear and those kind of, famously, you can see the photo of Google Velcroing on machines and they got batteries on it. Google used to say kind of proudly that we kind of take the DIMMs that we sweep off the floor and they buy. It was always funny because people kind of retain that, but they don't retain the epilogue to that story, which is like, oh, by the way, we learned not to do that because saving pennies, a bad DIMM, a DIMM that's going to return the wrong result can have an absolute blast radius that is far beyond a single bad DIMM. And Google learned like ECC is actually worth it, as it turns out. So the hyperscalers are kind of quietly figuring a bunch of things out about running at scale. And meanwhile, on-prem computing is left behind. Those folks that were running on-prem were not actually benefiting from any of these advantages. And in fact, this is accelerated by the fact that the folks that were kind of left on-prem were told that they actually don't understand cloud computing. And this became even more, over the years, became more and more acute. And what you have is now the divide that we have, where hyperscalers have modernity that you can rent, or antiquity that you can buy. And we've kind of taught ourselves that cloud computing, in order to have cloud computing, I have to be able to rent it. And the thesis of Oxide is that actually some people want to actually buy a computer and run elastic API-driven infrastructure. That we have this galactic false dichotomy where all of these innovations have accrued to the hyperscalers, and these innovations are sometimes basic, sometimes sophisticated. We've got the Oxide rack right here. There's a DC bus bar that runs up and down the Oxide rack. We do power conversion. We got a shelf in there that does power conversion from AC to DC. There are no AC cables back here because we've got a DC bus bar. This is not splitting the atom. Anyone who is running compute at scale runs with a DC bus bar. Every single one of those hyperscalers runs with a DC bus bar. You cannot buy a DC bus bar machine from those traditional on-prem infrastructure providers. And if you ask them about it, they'll tell you nobody wants it. It's like, nobody wants it? No, I think they do want it, actually. I think people do want to run compute at scale. And this is the massive false dichotomy that we see out there. And I think it's like, for those folks that are running on premises, and Steve and I were in this boat. We were at Joyent. Joyent was acquired by Samsung. And so we are trying to run cloud computing, elastic infrastructure, using the traditional on-prem vendors. And our reasons for running on-prem were good. Namely, they were economic. Samsung had bought the company because economically, they desperately needed to own their own compute and storage. They could not rent it. They could not rent it. It was going to destroy the company to rent it. And there are lots of good reasons, as it turns out, to own your own computer. Risk management, regulatory compliance, latency, increasingly. I want to have POPs. I want to be able to distribute what I'm doing physically around the globe. And this economic one is a big one, right? Where renting turns out, renting is expensive. Renting is great. Just like renting an apartment is great when you're young and you want to have that flexibility. But when it's time to settle down, it's like you actually don't want to be renting for the rest of your life. You want to actually own. And so too for compute. I think the thing that is most painful for those folks that are running on-prem is that they feel the world is treating them like dullards and laggards. Like, you haven't heard of cloud computing. And you know the only thing worse than trying to deploy elastic infrastructure on-prem is being told implicitly that you actually just haven't heard of the cloud. It's like, no, I have heard of the cloud. I want elastic infrastructure, but I need to run on-prem. And I think the folks feel, they feel dismissed.
Brian.
Yes.
Forgive me for breaking in.
Sure.
The question is, you talk about, the cloud has this increasing investment. They're investing relentlessly. They're doing innovation left and right and all this stuff. And here you are, a startup. You're trying to provide a cloud, I'll call it experience, in an on-prem envelope. Can you do this?
Boy, this sounds like an investor conversation that we would have circa 2019. And I think that actually, it's funny because when you talk to technologists, as we were looking at this problem and say, you know what, this actually needs new company formation because the existing players are locked in to their layers of the stack. And there have
server vendors, the
server
guys,
the
switch software guys, the virtualization.
And actually, in many ways, we can all blame Compaq. I mean, I love Compaq, amazing company, but Compaq is the origin of this divide because Compaq is like, we are not going to deliver the system software. That will be delivered by Microsoft. We will deliver the hardware. And Compaq realized, even in the 80s, that actually we need to deliver a bunch of software in here to actually fool the operating system into thinking that it's on that a single platform. So they are delivering more and more software, but they're introducing this divide. And if you're a software company with software margins, it's like, oh, you want me to also make the server? Why? Like, I'd rather have Supermicro can go do that. I'd rather have them go eat all that because it's painful, right? So we end up with this divide, and that software-hardware divide fundamentally is the most acute divide. The actually deepest problem that we have right now is that the hyperscalers are delivering hardware and software together, and the existing ecosystem, the on-prem ecosystem, is delivering hardware or software, and they are at a standoff. And even worse, I mean, it was like bad to begin with, but now you add private equity to the mix, and private equity begins to look at a company that's Avago, has changed its name to Broadcom, one of the companies it acquired because it's in polite conversation. It's easier to be a tech company than it is to be a private equity vehicle. But Avago bought Broadcom and then has also bought VMware. And so now it's like, oh, actually, sorry, you are actually now prey if you're on-prem and you're a VMware customer. It's like, oh my God, like this divide was already bad. But now you're actually going to try to monetize the software layer and you're making the whole thing doesn't make sense anymore. And I mean, there are so many problems with this, right? We've got this acute hardware software design. These systems are proprietary. Like we've had this open source revolution that has completely changed humanity. And yet, they think that my switch operating system that I run on-prem is proprietary, my orchestration is proprietary, my hypervisor is proprietary. The only thing that's actually not proprietary is this little like guest operating system, and then all of the software that's upbound from that, right? So Kubernetes, OpenShift, orchestration, that's all open source and great. But everything south of that guest operating system is all still proprietary, and it operates at cross purposes. So when this whole thing, you, the customer, are left as the integrator, and when the whole thing doesn't work, everybody spends all of their caloric budget trying to convince you that it's not their problem. And if you are a customer, this is so frustrating. And you hear, God, the number of times I heard, and I'm going to call them out, the number of times that Dell told me, you are the only customer seeing this problem. And for years, I just assumed Dell was lying to me. And then I realized Dell is speaking a kind of truth in that customers that are running at the scale that I wanted to run at were not Dell customers because it just didn't work any longer. So this is excruciating pain. And from a customer's perspective, the fact that I am left as the one, all of you are all pointing fingers at one another. VMware is pointing fingers back at Dell. Dell's pointing fingers at Cisco. Cisco's pointing fingers at everybody. They're all right often. That's even worse. It's like, actually, you're all right. It is all like there are issues on all of these things, and I am the only one that takes responsibility for actually delivering this. So this is the gulf that we went into. These are because this pain is the pain that we endured and realized that we needed new company formation. Everybody realized we needed new company formation. When we talked to technologists, like, yes, of course this needs new company formation, but you'll never get it funded. Or it needs new company formation, but you'll never be able to pull it off. And it's like, why are we letting that kind of fear prevent us from doing it? As it turns out, we can pull it off. We did pull it off. And we pulled it off because everyone realized this was important. Everyone realized that we needed hardware software co-design, true hardware software co-design. And by that, I mean, don't think of Oxide as a hardware company or a software company. The second you're thinking of Oxide as anything less than a systems company, you're not understanding what we're doing. We are delivering both hardware and software. And in particular, you need to deliver this hardware, design the hardware, so you can build sophisticated software on top of it. You actually can eliminate a lot of vestigial junk off. It's actually easier to develop this hardware. If you look at this board and you're used to a PC board, you'd be like, where is everything? That board is clean. And that board is clean because for a lot of reasons, like there is no A-speed BMC in here. We've got a service processor, a microcontroller, much simpler, not running some down-rev multi-user Linux variant that's riddled with vulnerabilities and has a password that's well known on the internet. Not to call out anyone in particular. The Calvin. But we don't have any of that. We've eliminated all of that to allow us to deliver better software upstack. So it is hardware and software, true co-design, true first principles thinking. Let's go back to the root of the problem. What problem are we trying to solve? What would we do if we knew how compute unfolded? Would we have a bias? Basic input-output system. This is a holdover from CPM. CPM is too old for me. I'm 50. I mean, at some point, when are we going to take these antiquarian abstractions and roll them into the street and light them on fire? We don't need a bias. And I will tell you that for all the things we did our own switch, we did our own compute sled, we did all of our own system software. It is the fact that we don't have a bias. Like, we were not crazy to start our own computer company, not crazy to do our own switch or our own compute sled. We were, however, absolutely crazy for not having a bias. And it's like, you will never pull that off. AMD in particular is like, you're not going to be able to pull that off. Because others have tried and failed. And apparently, if Google has tried something and failed, it's impossible for humanity. We actually knew that this was very hard, because this means taking that lowest level of silicon initialization. There is an entire network of computers on this die. It's amazing. That network of computers is not all that well documented. And what our software does is it actually does that initial silicon initialization, that initial bringing up cores, bringing up PCIe. And it does that not as part of a pre-boot step. It does that as part of booting the host operating system. We've actually, I think that the operating system should be in charge of initializing hardware. This is a radical idea that the operating system should actually initialize the machine. But by doing that, we delivered a machine that boots like a rocket, first of all, because as it turns out, when you're spending a lot of time in your BIOS, the BIOS doesn't know the software that's going to run later. So it has to do every bug and defect in humanity is jammed into a workaround in the UEFI BIOS. It has to work around a device that hasn't been made in 20 years. We don't have to do any of that. And we can make it much cleaner because we're taking this first principles approach, an approach that people thought was impossible. And again, it's a sad commentary on our industry that booting without a BIOS was thought to be impossible. We also have engineering rigor in the way we are building very much, and hand in hand with first principles thinking, is the rigor that we apply. Magic doesn't happen on this system. So if we see aberrant behavior, this is not like, well, let's go reboot it, maybe we don't see it again. If we see aberrant behavior, because we understand the whole system, have built the whole system, we can debug the whole system. And this one has been really interesting. Because when you actually understand the entire system, it is really surprising and scary where failures come from. I'll give you one very specific concrete example. We had an issue where all 10 of the NVMe drives reset. spontaneously reset. And as we're debugging, very transient issue, only happens on a very small minority of sleds, only happens under strange conditions. We're debugging it. And all along while I'm debugging it, my assumption is there's a firmware bug somewhere. I actually thought it was going to be in the AMD one. There's firmware in there we don't control, unfortunately. But I assumed there would be a firmware bug somewhere that's causing these drives to spontaneously reset. But as we are debugging it, actually, as it turns out, it was a dip on the 12-volt rail. The 12-volt rail was dipping to about 8 volts. It was going for about 7 milliseconds. So it's going about 3 milliseconds down, 4 milliseconds back up. And that dip, only the drives need 12 volts. Everyone else needs 3 or lower. So only the drives reset. And the actual issue was here on the IBC, the bus converter. We had a manufacturing issue that was causing the IBC to lose its mind very briefly and dip very, very briefly. The control loop inside of that bus converter, which is very sophisticated, as I've learned. But this was one of these that was almost terrifying. Because you think about how many times you got a Dell machine and you're like, or whatever, HP, pick Supermicro, whomever, drives reset. Like, what the hell is that? And then you don't see it again, you reboot, what have you. It doesn't cross your mind that this actual issue is far, far away. The drives are actually just a witness to a crime.
Or a rack level fault?
What's that?
Did it hit the whole rack? Because you described it as just hitting a sled, right?
Nope. Yeah.
So I'm a little. I feel like I'm about to ask a really dumb question. So everybody get ready.
Dumb questions are always good, by the way. When people think they're asking a smart question, that's often a dumb question, but the dumb question is often very
usually when people say they're going to ask a dumb question, they actually think it's smart. They just don't want to be embarrassed. Cloud software.
Yeah.
Cloud native, just did a podcast on that, is supposed to be really tolerant of fragile infrastructure, including unavailable infrastructure. So now you're talking about building all this.
Yeah. Oh, I love this. No, this is a great myth. In fact, I had this
myth.
It is a myth because, and again, this is a myth that kind of Google has given us, being like, we Velcro these things together, and its DIMM slipped off the floor, and your software should just deal with these machines going away arbitrarily. It is certainly true that it's helpful to have a robust system that can survive those kinds of failures. It's also true that it's impossible to build on a truly weak foundation. And so we had this, we had a DIMM issue, uncorrectable errors. This is in our past lives as a Dell customer. And Dell actually is like, well, wait a minute, this is the cloud, right? Does it matter if the machine resets? And I'm like, if it didn't matter, if the machine reset, I would power it off and I would remove it. It absolutely does matter. When you're building a resilient system, it is great to be able to deal with those kinds of failures. It is also true that any of those systems are going to enter compromised states as you have those failures. And they're going to recover from those compromised states. But you can only survive so many of those compromised states. You are eating away at the margin that you have to actually deliver a robust service. And this is what the cloud providers know. That's why the cloud providers have spent a lot of time developing very robust infrastructure that your software runs on.
Yeah, I guess I'm just kind of asking about the engineering, the point of engineering rigor. Sorry. Yeah. So, right? Because that point of engineering rigor can be on the sled. It can also be up in the stack.
For sure.
But it should be a defense in depth strategy. It's not that you fix this in one place. Yeah. This is the point.
Oh, sure.
And it's the point in the cloud systems as well, that they don't have, everything can fall over because there's a single failure. There have to be the series of multiple failures for you to lose that service.
That's right. And so you want to apply rigor. I mean, the answer is you want to apply it at every layer of the stack. And the rigor, when you're higher in the stack, is more being able to absorb those failures and have the service make forward progress. And that's great because you want to be able to do that. But you need the foundation of the stack to also be robust. And we are delivering that whole stack. So we are applying rigor, that kind of rigor, all the way up.
So it was a dumb question.
It's not a dumb question. No, it's a question. No, not a dumb question at all. No, that was
illuminate.
Actually, I've got one question. So you've got the kind of all-in-one, your software, your hardware, your rack.
Mm-hmm.
One of the reasons that particularly enterprise likes the modular approach is that if Cisco can't get them a switch, they can get it from from Aruba or Juniper or whoever. If this is kind of all locked in together, how do you deal with those supply chain issues and actually deliver the product to the people who need it at the time that they need it?
Yeah, it's a great question on supply chain, and we're very methodical about our supply chain. It's actually easier to deliver supply chain resilience when you have deep partnerships with folks. So I'll give you a very concrete example. So we had an issue we've got our fans here, our 80 millimeter fans, Sanyo Denki. We had a supply chain issue with Sanyo Denki. Because we are all in Sanyo Denki. They allowed us to do something that they have not allowed any other customer to do, even hyperscalers. We went into their BOM and helped them figure out where their supply chain problem was coming from. It's coming from a TI FET. It always is a TI FET, by the way. Because of our deep partnership with them, they allowed us to do, again, never done this before with any other customer, they allowed us to broker a FET back to them, and then they covered it under their warranty. So we got the FET for them to resolve the supply chain issue. When you dual source absolutely everything, you're not going deep with anyone. And as a result, you can't actually go problem solve when you have these real supply chain issues. The answer to like, I can't get my Cisco switch, so I'm just gonna get a Juniper switch. It's like, these are very different things.
Yeah, it's not what you want to do, but if you can't get one, you need to get something.
Actually what I want is I want the thing I want to show up when I need it. That's what I actually want, and that requires actually solving the supply chain issue, supply chain problem. And so we take that problem on very directly. In fact, we talked earlier about our transparency. Transparency, very, very core to what we have done at Oxide. We are open source, but it's deeper than that. We've got open design docs. We are very candid about our approach. So in particular, we have a podcast. There's an episode on the supply chain. Right, and we talk, and we have the folks that run our supply chain optimization talk about some of these experiences and go into the details. And the reason we have done that, and I mean, aside from the fact that we think it's the right way to build things, this is all about building the trust in our approach and our system, because it's what we would need when we're looking elsewhere. We want that transparency to have that trust. So what we've identified is a very real problem, and transparency is a big part of the way we solve that. Transparency into the way we're solving it.
Thanks.
All right, I'm at times. Thank you very much.
Talk to me about service, Brian.
Yes.
So, I mean, support. You've got all the software that you're supporting. Lines of code at the lowest level, all the way to the highest level, and networking, P4, and sleds and hardware. How do you support this monster?
Yeah. So I think in part this is why all of these things add up. All of our approach in terms of the codesign, the rigor, the transparency, all this adds up because it's very important that you have an artifact that is a highly supportable artifact. And when you actually have cobbled together junk, real hard to support. So in a previous life, I shipped a storage appliance, and that Sun Microsystems storage appliance did very well. In fact, it did too well. And we had lots of support issues, and all of those support issues, the ones that were most vexing and took most of our time, were at firmware at all these different layers of the stack that we couldn't control. And that is really hard because you can't actually fix those problems. That is just a drag on support. So when you have a system that's been engineered well, it's easier to support. Then you have a support team that is dialed in with the rest of the team. That is one team. Our mission, love our customers. Right? We are something that binds this company very, very closely together is the love that we have for the customers that are buying this. And because we know they've been unloved, right? They've been very, very unloved. And so when we do that, when a customer's got an issue, you've got an entire team, not just the folks that are actually on the front lines of that working support. You've got an entire team working as hard as they can to get that issue resolved. So we believe that we've got a model that we absolutely can support and deliver. And I think if you talk to our earliest customers, they will tell you that the support experience has been delightful.
You just have to throw bodies at it. And if you first start with that foundation and you get that time to discovery, time to remediation, you automate a bunch of this stuff because you have control, you invest in, I know it sounds silly, but we invested in like a slightly more expensive part by like a penny or two to have telemetry through the power levels of the system. We've done that across the whole system with the knowledge that we will eventually be able to wire all of that up in software and automate and kind of generate sort of answers to support about what this thing may be, rather than kind of blindly fumbling around or gaslighting the customer and You know, probably the software you're running up stack. No, we can't wait for a customer to say, I'm having a Mongo, like my MongoDB is like not performing well. It's like, great, let's go figure out what it is. We've got telemetry and visibility through the whole stack. We'll own the problem until it's resolved.